Okay, Professor Myers, so this is how we met foundation and Sitework.
So this is going to be quick, isn't it?
Jasmine, this is going to be legendary.
What?
Hello guys, today we're gonna talk about when we made foundation and Sitework.
Chapter 2.
So I will be starting with the discussion of foundations. So what's the function of a foundation? A foundation transfers structural loads from a building into the ground. So basically it prevents the building from collapsing. What it does is it receives various loads acting on the building and transfers them into the earth. So there's different types of loads when it comes to what's acting on a foundation. So the first one is a dead load. A dead load is the combined weight of all permanent components. This includes the structural frame, the floors, the roofs, and the walls, as well as the foundation itself. There's also live loads. So these are non-permanent loads, and these include things like the occupants in the building and the furniture. Next is the rain and snow loads. So these are downward forces that act on the roofs of a building. And there's also wind loads, which act laterally, downward, or upward, depending on the direction of the wind. There's also seismic loads, which are dynamic horizontal and vertical forces caused by the motion and the movement of the ground. And after this, we'll be discussing the settlement of foundations. So foundations must limit the settlement of a building. So a building will settle on a foundation no matter what, but the settlement does vary based on the soil below. So there's uniform settlement, which is when the settling occurs at the same rate throughout the building, but there's also differential settlement, which can cause the distortion of a building. So the settlement depends on the material that's under the foundation. These are the earth materials. So for the purposes of foundation design, earth materials are classified according to particle size, the presence of organic content, and sensitivity to moisture. So one of the main earth materials is bedrock. This is a dense continuous mass of mineral material, and it's generally the strongest and most stable of the earth materials. There's also soil. So soil is a general term which refers to any earth material that is particulate, and there's different kinds of soil depending on the size and the shape. So there's boulders, which vary from size but are 12 inches and above, and then there's cobbles, which are greater than 3 inches but less than 12. There's gravel, which are 3 inches to 0.18 inches, and then sand is smaller and ranges from 0.18 inches to 0.003. Gravel and sand are also referred to as fine-grained soils, and they're typically spherical shaped. There's also silt, which is smaller than gravel and sand, and then there's clay, which is flat or plate-shaped rather than the spherical shapes. So the ability of these soils to support loads without shifting depends primarily on friction between the particles to keep the particles from sliding past one another. So before designing foundations, soil conditions must be assessed, and there's different tests to do this. So these tests include test pits or test borings, and there's also load tests, which are used to see how big of a load a foundation can take. And then these tests are turned into reports, and the reports are then given to engineers in the design of excavations. Yes. So now Ali's going to talk about excavations.
So I'm going to talk about excavation and earthwork. So almost every building project involves some kind of earthwork at some point in its development, right? So the construction on undeveloped areas may start with grouting and clearing, which involves using heavy gear to remove trees, plants, stumps, big roots, and other surface materials. After building is complete, biologically rich topsoil may be removed from the area, and it's like separated for later use. So I'm gonna explain more in depth about excavation. So excavation is required for trenches for buried utilities, basement construction in order to reach undisturbed sufficiently firm soil for shallow footings, and to remove native soils that are contaminated or too weak or unstable to support the construction process. So any of a broad range of equipment, including trenching machines, bucket loaders, bulldozers, backhoes, and scrapers, can be used to raise and loosen particle soils. So for the excavation support, if the building site is big enough compared to the area that will be covered by the building, the excavation supporter can be benched or sloped back at a low enough angle to prevent soil from soaking back into the pit. So this angle is also known as the maximum permissible slope or angle of repose, and it can be small or frictional. So now I'm going to explain another type of excavation, which is called shoring. So shoring is construction method used to support the sides of an excavation and prevent its collapse. For large excavations, the most common types of shoring are soldier beams and lagging, and as well as sheet piling. So the soldier beams and lagging consist of steel columns that are called H-piles or soldier beams, and are driven vertically into the earth at close intervals around an excavation site before digging begins. And as the earth is removed, the lagging is frequently consists of heavy wood planks, and they're placed against the flanges of the columns to retain the soil outside of the excavation. So when it comes to soil mixing, this is one method that it's also called ground improvement or earth improvement. So these terms refer to any of a variety of methods for altering the properties of soil in a place. And soil mixing, for example, can also be used to create cut-off walls to prevent water seepage into excavations, and it can also help by stabilizing or strengthening areas of weak soil around or under the buildings. It can also remediate biologically or chemically contaminated soil. So I'm also going to cover some methods of constructing walls. There's a type of wall called slurry. So the slurry wall is a more complex method of construction, and is more complete, right? So it consists of steel reinforced concrete walls that are placed onto the ground, and it has like even more stories below in the surface, right? So before excavation takes place, it's like the reason why constructors love it is because it is a relatively expensive form of excavation support that is usually economical only if it becomes part of the permanent foundation of the building. And the excavation for a slurry wall is performed with a narrow clamshell bucket operated by crane, and it's guided by temporary guides at the ground surface, and it defines the edges of the wall. So as the trench deepens, the tendency of the earth walls to collapse is counteracted by maintaining the trench full at all times with a viscous mixture of water and bentonium clay or polymers that are also called a slurry, right? So this slurry exerts pressure against the earth walls, and it helps holding them in place. So when the trench has finally been excavated to its full depth, the steel tubes that are also equal in diameter to the width of the trench are inserted vertically at intervals to divide the trench into sections of a size that can be reinforced and concreted conveniently to the size that it's needed to the site, right? So into each section, a steel cage of reinforcing steel is lowered, and concrete is poured from the bottom up using a funnel and tube arrangement called a trimmer. Here we can see Jasmine carrying the rocks, and as you can tell, it's a very hard work.
Hey guys, it's Jasmine. Today I will be showing you guys how to determine what type of soil a rock is. So the first one is a boulder. So boulders are 12 inches in diameter or greater, and there is a test for this. So to know how much or what type of rock it is, you have to pick it up. So if you could pick this one up with 2 hands. So as you can see, you need 2 hands to carry it, and that's how we know that it's a boulder. So the next one is the cobble. So cobble is when a rock is less than 12 inches in diameter but greater than 3. And for this one, you know it's a cobble because you could pick it up with 1 hand. Like that. So yeah, that's how you know. Okay, so next I'm going to explain how to determine if it's gravel or sand. So this is a piece of gravel right here. We know that because you could lift it with just 2 fingers. So gravel ranges from about 3 inches to 0.18 inches. And then the next one is sand. So this is sand right here. As you can see, it's pretty hard to pick up a single particle. Sand is when a particle is less than 0.18 inches. And then the next are clay and silt. So clay and silt, it's like really hard to pick up just a particle. They're super tiny. And yeah, that's how you know that it's clay or silt. 1.
Fun facts with game lives.
Okay. Hello, I'm Christian, and this is Professor Myers. Thank you for joining us.
Of course.
And we are doing chapter 2, and it's called Foundations in Sitework. So I did pages 60 to 75 on the Foundations in Sitework. And what this was is kind of taking all the elements out of, like the earth elements, out of the foundation. So anything like waterproofing, any drainage, keeping thermal heat inside the substructures, like any basements, and also radon and gas control, keeping the gases out of substructures as well. Okay. So like things like with drainage systems, to reduce the volume, water volume and pressure of the water. There's a few things you can add. There is drainage mats. There is pipings that can go along all the perimeter of the foundation, and sorted gravel around those pipings as well. To filter out all the sediments, all the just rocks. So the drainage pipings can't get clogged. Right. So when the water hits the drainage pipes, it would go down into the gravel, into the in the drainage mats. It would go down into the gravel and then into the pipes. Where it can lead, into the sewer system or wherever the city is to. And if there's too many excess water, the pipes can also be added to the below interior slab, below the slabs.
Mm-hmm.
And when there are substructures, barriers can be also added as well, to increase or decrease water entry from any substructures, like moisture resistant cement that can be applied to the basement walls, which is called dam proofing. I guess you know what dam proofing is.
Well, I do. So with do you have any names of the dam proofing? Like, what sort of materials would you use for that?
All I have right now is that it's just moisture resistant cement. If you want to add anything with dam proofing, you could go ahead.
So there are several materials that you could use for dam proofing. Bituminous, like a petroleum, tar-based substance that you can put on concrete walls to create a barrier. It's something that might be water repellent and water resistant.
Of course.
Typically it's some sort of tar, like doing basement roofing. So the materials you put on the roof, you would also put on the walls, subgrade. How serious do you think the dam proofing is in this part of the country?
I'm not too sure. I just know that damp-proofing is more of like a minor type of waterproofing, type of like water-resistant thing. You know what the chapter says is that waterproofing is better because it uses more robust type of materials. Waterproofing could be like anything. It would be like a membrane. So there will be like a liquid membrane, and there will also be like a membrane of a sheet metal or use anything sheet that can manufacture in a factory or anywhere. And what this liquid membrane is, it's a bunch of materials. So like it consists of plastic, it says your asphalt compounds, any synthetic rubber, which is applied to the walls of the foundation or the substructure. And with the sheet membranes, they can be harder to put on the foundation since it's more difficult with like complex shapes of the walls, as you can say. And the thing about the sheet metal membranes, waterproofing, is that it can be also vulnerable to like any leakage as well, on the slits of the sheets. But that would be all I have of the waterproofing and drainage. If you want to add anything, you could. We can keep going on.
What's next? Just in terms of what's the next range of topics?
So what the chapter also talks about is thermal insulation. I don't have it really talk about a lot of it, but it just talks about how obviously keeping heat inside the building is priority. Wanting to do that. So with outside the building, a water-resistant insulation is good. Also inside the building, any mineral fiber insulation boards can be placed on the inside as well. And that's really all it talks about for thermal insulation. If you have any other things you want to add for any thermal insulation?
Well, I think both the damp proofing and waterproofing ideas, as well as the insulation, is not necessarily that pertinent to this part of the country because we're pretty temperate.
Oh yeah.
And even in terms of water issues, typically there would be issues down here in the valley, right? The closer you are to the river, the more likely that there's groundwater that you need to either remove or protect from infiltrating your foundation. Similarly with your insulation, we don't really hit freezing temperatures here, so there's not as much need, but those are both important aspects of construction because they're really hard to go back and fix. I mean, you could probably put the insulation on the interior if you wanted to do that and you didn't have enough insulation to begin with, but damp proofing is a really major issue because you want to do it before you backfill. Right? When you backfill and put the dirt in to get back to your level grade, it's really hard to dig that all out and fix like a leaky foundation. So it's really important to have.
Would you think it's more important for, like, let's say an architect would, let's say, go to a firm like somewhere in, let's say, Seattle where it rains all the time? You think this would be like more pertinent and more important?
Well, it's
understand.
Certainly in areas that have either high water tables. So it used to be that the water table around here, especially with flood irrigation and things like that, like in the lower valley or upper valley, there might be more water issues.
Okay.
And it's really challenging to come back and fix those after the fact. Like once you backfilled, it becomes a real issue to fix.
Okay. Thank you for putting your point in. And then the last thing it talks about this chapter at the very end is radon and gas control. I guess you know what radon is. It is a cancer-causing gas that emits from the soil, and it can sometimes seep through the cracks, and it can cause health problems in the long run. And so there are many ways to control this. In the chapter, it says here that you can include layers of gravel beneath these concrete slabs, and over these gravel layers, it says here you can add plastic sheets. Can be added. even coating on the outside of the walls with waterproofing. And I think the main one was some vent pipes as well. And usually it says here on this that those would really be used in like any residential buildings or any school buildings. And when there is, excess, a high concentration of this radon gas. It says here that you can call it a sub-slab depressurization can be added. It's like, installing fans inside the vent pipes. And, these fans would, reduce any air pressure and, cause gas to be, effectively extracted.
Right, so I'm not familiar with the barriers and things like that. The one time I've had to provide that was by putting in fans to ventilate both the basement area or because yes, you can have concentrations of radon. It usually comes from the bedrock, and once it gets in the house, then obviously it can be breathed by the inhabitants. And it's not so big of an issue if it's just you're an occasional visitor to a building, but if you're living there or constantly exposed to it, definitely
All right, thank you, and I think that should be it. That's all the end of the chapter we talked about, but I think we should be good. Thank you, Mr. Professor Myers. All right, thank you for joining us, and thank you.
Thank you.
Here I dreamt I was a soldier, and I marched the streets of Birkenau. And I recall in spring the perfume that the air would bring.